All right. And our components, do we feel pretty good about breaking down into components because we just did 2 of those together? Yes, we feel good about those, or no, we need to do one more?
Feeling good.
Feeling good, okay. Okay. All right, so projectile motion. Anytime we talk about projectile motion, we're thinking about an object that's moving through the air, so it's not connected to anything, it's not held by a string, it's moving freely through the air in 2 dimensions. So when I say 2 dimensions, what do you think that means?
It's going on a flat plane. Up. It's like X and Y's.
Okay, yeah. It's not moving depth-wise, that's fine. 2 dimensions, what do you think our 2 dimensions are? X and Y. Okay, so it's moving vertically and horizontally. So if something's rolling along a table, is that a projectile motion?
No. Yes. It's not moving vertically.
Not moving vertically. If it's rolling along a table,
yes.
Not a projectile because it's not moving vertically. Right?
Yeah.
If something rolls off the table, right? If I'm rolling this on the table and it leaves the table and now goes to the ground, is it a projectile?
Yes.
Yes. Okay, so it's anything that moves freely through the air in 2 dimensions. Okay? So lots of things that are flying objects, right, are projectile motions because they're moving through the air both horizontally and vertically. Okay? The thing about projectile motion is that we don't really care what started the object in motion. We don't care about the kick. We don't care about the push or anything that put that object into motion. We care about the object once it begins to be a freely falling object. So as soon as it becomes its own entity in flying through the air, that's when we start looking at it. We don't care about the process that put it into motion. Okay? So we care about its initial velocity once it's becoming a freely falling object. Okay? When we deal with our projectile motion, and these are objects that move vertically and horizontally, we have to go back to using negative 9.8 as our vertical acceleration. Okay, because as it's moving through the air, gravity will still be acting on it, even though it's moving horizontally as well. Okay, so you can use negative 9.8 as your vertical acceleration. Right, we learned in our forces chapter that you have to deal with horizontal and vertical components totally separately. So that means we're going to have a different value for horizontal acceleration and vertical acceleration, and we're going to talk about that here in just a little bit.
We'll have the 2 answers for all of them?
Not necessarily, but we have 2 sets of equations. We're going to have a vertical set of equation and a horizontal set of equations. So that'll allow us to look at each of those things separately.
Are we going to like add them together or something?
Kind of, essentially. But usually it'll just ask you for, what's your final vertical velocity or final things like that. So you'll just really look for one of those variables. Okay, if you look at an object's path through its projectile motion, it's called its trajectory. Have you heard that word before? Trajectory. Right, that's just going to show us where our object's going to go if it's moving in a projectile path. Okay, and Galileo was the first one that really described to us projectile motion in that you have to look at its vertical and its horizontal components separately. Okay, Galileo also discovered one other lots of big things, but we watched a little video about Galileo. Do you remember that? Or not so much?
Not so much.
Okay, he was the one that also told us that light objects fall at the same speed as heavy objects. Right, so he had the ability to understand, basically separate a lot of things in terms of its equation, in terms of its, speed and all that kind of stuff. But he understood that we have to do vertical and horizontal components separately. So as something's moving through the air, it doesn't travel the same speed vertically as it does horizontally. It doesn't fall at the same rate vertically as it does horizontally, things like that. Okay? All right, do we have what we need here? Okay. These ones should look familiar, yes or no? Right, these ones should look familiar. So you should already have these. You don't have to write them down again. But what we're going to do is we're going to manipulate these equations to represent just vertical properties and just horizontal properties. So we're going to take these sets of equations and we're basically going to have kind of a new set of them for vertical and a new set of them for horizontal. Okay, and so that allows us to look at purely horizontal components using one equation and purely vertical components using another equation. Okay, so we're going to take your kinematics and we're going to give you a specific set of equations just for projectiles. So you might want to put on your equation sheet, these equations are going to be specifically for projectiles. Okay. Okay, so here's your first new set of equations. These are for vertical components. Okay, and so I want you to just look at it really quickly before you start writing it down, and I'll give you some time. Okay, this equation looks almost exactly the same, right? What's the only thing that's new? Right, we added the y, right? So it's telling us that we're looking here at velocity in the y direction final. Okay, so velocity y final. That means this is final vertical velocity, which means this variable right here would be telling us what? Initial vertical velocity, right? So each of these little subscripts means something. They tell us something. Okay, so go ahead and get it written down. All these equations written down, and then we will talk about kind of a little bit more in depth what they mean and some things that we're going to assume about each of these equations. Okay, and make sure you write these as your vertical equations. So equations for projectiles, and then you're going to have vertical and horizontal. In this first equation, we looked at the fact that now it's not just final velocity, it's final vertical velocity, an initial vertical velocity. When we say a sub y, that means our vertical acceleration, and we know our vertical acceleration is always equal to negative 9.8 meters per second squared. Okay, so vertical acceleration is always negative 9.8. Always, always, always. Okay, so that AY variable will always be negative 9.8. And realistically, I'm usually going to leave that Y off because we know our vertical acceleration is always negative 9.8. So from here on out, when you see these equations, it'll really just be an A. Okay? Time is the one thing that can go back and forth between X and Y, so we don't have to put a subscript with that in terms of horizontal time or vertical time, right? It would be the same amount for both of those things. Okay, what variable are we used to seeing right here? Usually a D for distance or displacement. So what do you think this Y final stands for now? Instead of distance, just in general, vertical distance, right? The only thing that's different is that we're looking purely at vertical distance. So this is our vertical displacement, initial and final. Okay? Still, this VYI would be initial vertical velocity. This is still time. That's gravity and time again. Okay, so these equations, V is always velocity, Y tells us vertical, I tells us initial. So each of those things means something to us or should mean something to us. Okay, in the last equation, nothing really changes here. Final vertical velocity, initial vertical velocity, gravity, and vertical displacements.
Wait, what's Y again?
Like our final vertical displacement. So how high above or below it is from where we started.
There's still pretty much
Still a distance, yeah, but the Y tells us that it's only vertical distance.
Would that usually be like 0 unless they ask like after 2 seconds or something?
Yeah, Y initial is always going to be 0. Remember, because our motion always starts from the beginning. Like our origin always goes at the beginning of the motion.
Yeah.
So if our Y final was negative 50, what would that tell us about the end of our motion? Where would it be ending up? How many meters?
Where it started?
If it was negative 50?
Oh, down. Wait, yeah.
Why isn't it DY at?
Below 50 meters?
Below 50 meters. Below 50 meters from where it started.
Why isn't it like DY at? Or like
Rocks off the
top? You know?
These ones in the box are your new ones. These are horizontal equations. I'm going to show you how we went from our original to these new ones. Okay? So in the box are the ones you need. These are your horizontal projectile equations. Okay? I'm going to show you how we get from the left set to the right set, but these are the ones that you need, the ones in the box. All right, so I'm going to show you how we get to this shorter set of equations. Right? This is a pretty short set of horizontal equations, so I'm going to show you how we got there. Right? Here's our original kinematics equations with our x variables plugged in. Right? Velocity x final equals velocity y final plus ax times time. Okay? So, when we look at the acceleration of an object in the horizontal direction, think about an object as it flies through the air in its projectile path, right? In general, a projectile has a path that looks like this, right? It goes up and it comes back down. Would you agree? Okay, does at any point that object slow down or speed up in the horizontal direction?
No.
No. Does it speed up or slow down in the vertical direction? Yeah, right? As it approaches its peak height, it slows down. But does it stop altogether? No, it's got to still keep moving forward. So horizontally, our objects have constant velocity. Okay, and that's something that we need to write down here. A sub x is always 0. We have no horizontal acceleration because things don't speed up or slow down in the horizontal direction on their own. Okay, so a sub x would always be 0. So in this equation, if a sub x is 0, I can just take it out, which is how we get to this equation right here. Okay? And this equation tells us horizontal velocity final is equal to horizontal velocity initial. Right? That's all that's telling us, is that we don't change speeds throughout the whole process in the horizontal direction. Okay, so once we solve for initial horizontal velocity, that's also our final horizontal velocity. Okay, it will not change. Things don't randomly speed up or slow down in the horizontal direction. What would cause something to speed up or slow down in the horizontal direction? As it's flying through the air, what would cause it to speed up or slow down in the horizontal direction?
Walls.
Yes, some sort of outside force, okay? A wall or air, right? Wind, those things would cause that. Remember, we live in a perfect physics world, right? So we assume nothing weird happens, okay? Next equation, x final is equal to x initial, vxit times 1/2 at squared. We know a sub x is 0, so this whole thing gets dropped. We know our initial displacement is always 0, so that gets dropped, which is how we get to this equation right here. Okay, so we're just dropping out variables that are going to be 0 all the time. Okay, and then this one, if we drop this 0, right, because we know acceleration is 0, that would leave us with velocity final squared equals velocity initial squared. Is there any reason for us to have an equation that looks like this? Oops. Right? It looks exactly the same as this. There's no reason for us to have both of those. Okay, so horizontally you have only 2 equations. Okay, what's the one variable that lets us go back and forth between horizontal and vertical? Time. Good, time. Okay, that's something that you need to think about. That's the only variable that can overlap between these 2 sets of equations. Okay? All right, so these are a couple things we're going to assume with our projectile equations. We assume that air resistance is always negligible, right? We can ignore air resistance. We're going to live in that perfect physics world where we don't have air resistance. We're not going to have anything slowing down our motion as we fly through the air. Okay, we always assume that our motion begins at t equals 0. So the time that we solve for is always going to be the time that it takes for the object to go from its initial velocity to its final velocity. Right? These are not any new assumptions that we're making. Right? We dealt with these in our regular kinematics problems too. Okay, we are always going to put our origin at the beginning of the motion. Always, always, always. Okay, which would mean for us that our vertical and our horizontal displacement initial would both be 0. Okay, always, always, always. So yi and xi should always be 0 because we're going to start our motion. That's where our origin is going to go. Okay, wherever our motion starts from, that's where the origin goes. Okay? So x of I and y should always be 0. So if we end up below where we start, that means our final displacement would be what? Negative. Okay, so just something to think about. Okay, so this is what I'm talking about here. If I'm standing on a cliff and I shoot something off the cliff and it flies through the air and it lands right here. Right? This is where the origin goes. So my final vertical displacement would be negative, however tall this cliff is, right? Let's say it's 30 meters. Our y final would be negative 30 meters because we're ending up 30 meters below where we started. Okay, last assumption we're going to make is a sub x equals 0. We just talked about that a little bit ago. So no acceleration in the horizontal direction. And if you look at your horizontal equations, there's not even an a in there. Right? We took out the acceleration in the horizontal direction because we know that it's 0. Okay? Okay, you don't have to write this down, just think about what's happening here. Which will hit the ground first? The ball rolled off the table or a ball dropped straight down from the same height? Okay, so if I have a ball that rolls off the table and I drop a ball at the same time, which will hit the ground first? How many of you think the dropped ball will hit the ground first? Okay, how many of you think the rolled ball will hit the ground first? How many of you don't have a clue? Okay, here's the thing. An object that's projected horizontally will hit the ground the same time as an object that's dropped from the same height. So why do we think that is?
Because
It didn't pick up any acceleration going in any vertical direction.
horizontal velocity doesn't change.
Okay.
Horizontal velocity doesn't change.
Drops have a straight path.
Kind of. What do horizontal and vertical components affect each other?
Yes.
Come on now.
Nope. So horizontal and vertical components have to be solved separately. That's why we have two sets of equations. So the only thing that matters in this problem is the height at which it's being dropped from. So as long as they're falling from the same height, theoretically they'll hit the ground at the exact same time. Okay?
What if like if you roll it hard, it's gonna do
Like that.
yes, yeah.
Mm-hmm. So even though the yellow ball is moving horizontally, these are frame-by-frame shots of, like time-by-time shots of this object. So even though the yellow ball is moving horizontally, it's still falling at the same rate. Okay, its horizontal motion does not affect its vertical motion in any way. So the ball that's dropped straight down and the ball that's projected are going to hit the ground at the exact same time. Questions? Okay.
It's flu season.
All right, we're going to look at a few things to help us solve problems, and then we're going to jump into some examples. Okay, there you go. You don't have to write these things down, but these are just some things that I want you to remember. Okay? You have to read the problem and draw the diagram. If you do not read the entire problem, chances are that you're going to do extra work. Okay? If you don't read the entire problem, you don't know what they're asking for, you might do something extra or something silly. Okay? So read the whole problem and draw the diagram. Diagram can be extremely simplistic. Okay? But you need to draw one so that you can understand, is the object going to land below where it started? Is it going to land above where it started? Is it going to move forward or backward or whatever you think it's going to do? You need to have that diagram with you. So it can be very simplistic, but you need to have one. Choose an origin and an XY coordinate system. We'll always use to the right and up are positive, to the left and down are negative, just like we have in the past. So that coordinate system does not change. We're going to look at X and Y separately. So you'll need to have your variables for X and your variables for Y. So when you write down and take things from the problem, you need to really be thinking about, is this a vertical velocity or a horizontal velocity? Is this a vertical displacement or a horizontal displacement? Because those things make a difference. Okay? You'll list your things in your origin, in your margins on the side. Remember that horizontal velocity never changes throughout its whole path. So you'll have Vxi and Vxf would be equal to each other. Something to think about here. At its highest point of any projectile motion, Vy final is 0. Right? If I'm looking at just this point, right? I've reached halfway. I'm at my highest point. Remember, we know it comes to a stop when it reaches its highest point. It does not come to a stop horizontally, but it comes to a stop vertically. So at its highest point, Vy final would be 0, right? If we're just looking at the front half of that motion, which we'll do a lot for projectiles. Okay, so that's something that we want to think about. And if we ever ask for the velocity before hitting the ground, or what's the velocity at the end of the motion, remember, we're not talking about when it comes to a stop after it hits the ground. We're talking about like the instant before it hits the ground. So we need to think about that in terms of, usually that final velocity would be negative because it's coming in a downward direction, things like that. Okay, does that make sense? Okay. All right, let's try some practice problems. All right, go ahead and get written down what you need to. These first types of problems that we're going to talk about are what I call rolling projectiles. So these are examples of things that leave the table or the cliff or whatever, leave it purely horizontally, and then they start to become a freely falling object. So we're not dealing with launched projectiles yet. These are going to be what I consider rolling projectiles. All right, so go ahead and get written down what you need to here, and then we're going to start pulling out variables and seeing what we need.
Am I going to put dxi and dyi have like two sets of...
You can, yeah. I won't use a d variable. I will say x initial, and that's our initial displacement, x direction, or x final. Okay, or y initial and y final. These two are always going to be 0. Okay. So here's my cliff. He's driving off horizontally, and he's going to end up over here somewhere.
Is he going to be alive?
I hope so. Okay, so it says he speeds horizontally off the cliff. The cliff is 50 meters tall, so that means this is our vertical distance, and he's going to land 90 meters from the cliff, so that's this distance right here. Okay, so what variables would those go with? The 90 meters tells us what variable? Yeah, the horizontal displacement, right? So that would be x final is 90. Okay, our y final tells us our vertical final displacement. So what number do we know is going to go with that?
Negative 50.
Good. It's going to be the 50, but why is it negative 50?
Because you start at the top of the cliff.
Good. So here's the origin. We're going to land 90 meters to the right of where we started and 50 meters below where we started. Okay, so does that make sense where these two variables come from? Okay, and does it make sense why both of these are 0? Okay, they will always be 0 because we're going to always choose the origin to be at the start of our motion.
What's the T stand for?
Time, right here. Is that what you're asking about?
On the thing you drew in the top.
Oh, sorry, that's just the origin. Like that's where the like our coordinate system would start. Yeah. Okay, how fast must the motorcycle leave the cliff if it's to land 90 meters away? So tell me, what variable are we solving for here? How fast? Okay, so we're solving for velocity. Are we solving for velocity in the x direction or the y direction? X, right? Because he leaves the cliff purely horizontally. Can we visualize what's happening here? Right, he's driving along the cliff, which is purely horizontal. And when he leaves and he's going only horizontal for just an instant, and then gravity starts pulling him down. Okay? So we're solving for Vxi, right? Which is really the same thing as Vxf because it doesn't change. But that's essentially what we're solving for. Right? We're solving for how fast horizontally did he leave the cliff. Does that part make sense? Okay. So look at your equation sheet. What do we need to have to solve for Vxi? Okay, we either need to have Vxf, which those two numbers are the same, so that's not going to help us.
Time and x1.
xf and time.
Good. We need to have x final equals vxi times time. Okay? So we don't have time. Time is the one thing that can go between vertical and horizontal equations. It's the one thing that can overlap. So a lot of our problems are going to need us to solve for time first before we can do the other part of our problem. Okay? Most of these projectile type equations, you're going to have to do two equations. Right? It's going to take two parts. So I already gave you the equation that we need to solve for time, but I'll kind of explain why we picked this one. Right? We're going to use this equation right here to solve for time. Because if you look through your vertical equations, we don't know our final vertical velocity, so we can't use the first or the third, right? But how do we know our initial vertical velocity? It's 0. Okay, and so Garrett, do you know why that is? Almost. Okay, it started moving purely horizontally. Okay, so if it's a rolling projectile but it leaves the cliff purely horizontally, that means that it's not moving vertically yet. So its initial velocity is purely horizontal, so that means its initial vertical velocity is 0. Okay, so that's kind of tricky. On these, what we call rolling projectile problems, it says it's shot horizontally or it flies horizontally off the cliff. That should be a clue for us that Vyi is 0. Okay, our initial vertical velocity is 0. Okay, so I will keep reminding you about that, but that's something that we should think about. If it's leaving the cliff purely horizontally, that has to tell us that our vertical velocity is 0 at that point, at that very instant. Okay, so this is 0. All right, so I'm going to change colors here real quick so we can look at this equation. Our y final we said was negative 50. Our y initial we know is always 0. Vyi times time is 0 because our initial velocity is 0. So here we're going to drop quite a few parts of our equation. What do we know the acceleration is in the vertical direction? Always. Good. Negative 9.8. And we are solving for t. Okay, do not forget that squared on that t. That's easy to do. Okay, so if we take out the zeros, right, that leaves us with negative 50 equals negative 4.9 t squared. What do a lot of you want to do here? Right, a lot of you will add that 4.9 over. Right, but that's not how it works because it's connected to that t squared. So you're going to take negative 50 divided by negative 4.9. And that would give us 10.2 equals t squared. And then we would square root that answer.
The velocity initial 0.
Vertical initial velocity is 0.
So that means xf is 0.
One more time.
Would that mean xf is 0?
No, our xf is our final horizontal displacement, and that's 90 meters. Because we want our car to land 90 meters away from where we started. X final is a displacement. V is a velocity. Okay? So we solve for time. We want to go back here and solve for Vxi because that's our overall goal. So if our x final is 90, Vxi times 3.2.
I thought you said, why are you times? You say times it right here. What did you say?
No, we're going to just take our time and bring it back up to solve for Vxi. So x final is 90. That's where I got that. Vxi is what we're solving for, and then time is 3.2. Sorry.
I thought you said 3 times.
Okay, no, sorry, just 3.2.
Is dx 0? Dx value.
If you're using that, dxi is always 0. Final horizontal position is 90 meters because we want to land 90 meters away from where we started. Okay, did we end up with 28.2 meters per second? That's just, yeah. Okay, so this is another example of a rolling projectile. Okay? And when I say rolling projectile, I just mean it like it's leaving the cliff or the table or whatever, purely horizontal, and then it's falling, like something rolling off the table. Okay? So this is, again, another example of what I would call a rolling projectile. It's thrown horizontally from the top of the cliff with a horizontal velocity of 3.21 meters per second. For how long is the rock in the air? And how far from the base does the rock land? Okay? So there's a couple things in this problem that need to jump out at you. The first of which, it says it's thrown horizontally. That right there tells us that this is that rolling projectile, which means Vyi is equal to 0. Okay, so that means the second it leaves the cliff, it's traveling only horizontally. Okay, so that's just something that we need to have as kind of a clue here on our rolling projectiles. Velocity x final would be 3.21, yeah. We don't know velocity y final. So again, our problem looks like this. It leaves the cliff purely horizontally. It's going to land right here somewhere. Our cliff is 24 meters high. Here's the origin. That's where we're starting from. And we want to find this distance. Right, and we also want to find time. So there's two things we need to do here. Okay, how long is it in the air? And how far away does it land? Okay, does the diagram part make sense to everybody? Why I drew it looking like that? Right, we want to find this distance. And this distance would be called x final, right? That's what we're solving for there. All right, so let's start picking out some of these variables. When it says it's thrown horizontally, that automatically tells us that our initial vertical velocity is 0. Okay? Our cliff is 24 meters high, so what variable does that tell us realistically? Okay, we know y initial is 0, so what does that y final have to be? Negative 24, because it's going to end up below where it started, 24 meters. Okay, does that part make sense to everybody? Our initial displacements always have to be 0. Okay, x final we don't know, because that's what we're solving for. Time we don't know, because that's what we're solving for. Okay. Which of these two do we need to do first? Oh, I forgot one more variable. Right, we know our horizontal velocity, so Vxi is 3.21. Okay, and which of those do we have to do first? Time. We have to do time first. And so if you look at your equations, can we solve for time with our horizontal equations? No, not going to work, right? So we have to use our vertical equations to solve for time. Which one should we probably use? The second. Okay, we don't know our final vertical velocity. And there's no reason for us to really solve for that first and then solve for time and then solve for horizontal displacement, right? So just use that second equation to solve for time. Okay, so when I say second vertical equation, it's the one that looks like this. Okay, and for these rolling projectile type problems, we get to drop a lot of that equation, right? We know our y final is negative 24. We know y initial is 0. We know initial velocity vertical is 0. So we get to drop a lot of that. Yeah, sorry, what was your question?
What's the difference in yi and vyi?
Okay, yi is a distance. So we're saying its initial distance is 0 because it's at its starting point. Vyi is a velocity in the vertical direction. Okay, so its initial vertical velocity is 0, because it says it was thrown horizontally. So that the second it leaves the cliff, it's only moving horizontally. Okay, does that make sense? So the v will always be a velocity. It'll be meters per second. Y is always a displacement, so it should be meters. We need to divide over that negative 4.9, and then don't forget to square root it, okay, because it was t squared. So I ended up with about 2.21 seconds for my time. Okay, then how far from the base does the rock land? What does that variable mean that we're going to solve for? XF, good. So our final displacement is what we're solving for. We know Vxi is 3.21 because that was given to us in the problem. So all I'm going to do is multiply that times my time. A diver running 4.0 meters per second dives out horizontally, so that's our clue that it's a rolling projectile from the edge of the cliff, and 2.2 seconds later he hits the water. How high was the cliff, and how far from the base did it land? Okay, so you're looking for two different things here. Okay, 4 meters per second was our Vxi. It tells us it dives out horizontally. So what does that horizontal word in the problem, what clue does that give us? That Vyi is equal to what? 0. Okay? So that comes from this telling us it's moving horizontally at the beginning of its motion. Time is 2.2. We want to solve for x final and y final. Okay, what are the other two variables that we always know? The initial is 0 and x initial is 0. Okay, so these are the variables we should have been able to pull from that problem. This is the hardest one. Right? It comes from just reading the problem and understanding what that means. Right? It dives horizontally, so that means the instant it leaves the cliff, he has no vertical motion, so Vyi would be 0. Okay, so for my x final, I think we got about 8.8. And our y final, we got about 23.7. Yes, negative, you're right. You're right. Okay, so how far, well, how high was the cliff? You can really turn it around and give it positive to say it was 23. I'll take either one. Okay, so you can answer it with that negative because it's landing 23.7 meters below where it started. It's really asking for how tall the cliff was, but I'll take either one. Okay? Questions here? Okay.